All right. Okay. All right, we'll get started. For those of you, two of you so far who are new here, I also have remote high school students at both Lafayette and Eureka that are, at least I know that some students from Lafayette are there. So far, I'm not seeing anybody from Eureka, but so they watch remotely and they can input questions also. Okay, I'm Jim Smith. For those of you who don't know who I am, welcome and welcome back. To Calculus 3. What I want to do today is definitely go over the syllabus and just take a look at the tentative calendar, go over a few other things. We'll see whether I even get started with section 12.1. Okay, may not make it that far. Because on Mondays, for those of you newer, we just meet for 50 minutes. It's a 5-hour class, but meet for 50 minutes on Monday. On Wednesday and Friday, the class starts actually at a strange time. It starts at 10:06, which has to do with high school schedules, and it goes until noon, or well, 10 to 12. All right. Let's just look here. The textbook, as you all know, is the 7th edition of Stewart. And so we're going to start in chapter 12. 12 and 13 are going to be basically considered like the first unit, and then we'll have a unit test after that. Then we have chapters 14, 15, and 16. So this is multidimensional calculus, so we're going to be looking at three-dimensional space. We're going to be looking, first of all, at vectors, what vectors are, and how we can do certain operations on vectors and what those mean. That'll be in the first two chapters that we'll look at. Then we're going to look at what are called partial derivatives in chapter 14. That's going to be, again, this is going to be functions of more than one single variable, like it would be a function of x and y, or maybe x, y, and z, and seeing what a partial derivative is, what a directional derivative is, and what a gradient is, okay? And that's in that chapter 14. Chapter 15, we're going to be looking at integration and looking at integrating over a surface or an area. Those are double integrals. And then we'll also be looking at what are called triple integrals in that section. And then finally in 16, vector calculus, we'll be looking at Green's theorem and divergence. And we'll see how far we get in chapter 16, all right? As we all know, the weather can wreak some havoc on the schedule, so we're hoping that most of the crazy weather is behind us, but it's only January the 13th, so who knows, right? So I'll get to the tentative schedule in just a minute. And again, the word tentative is certainly important. Okay, everybody should have had at least a grade C- in Calc 2 for this class. And here, the faculty room is room 211 for those of you who are new downstairs. The best way to as far as questions either before or after class is the best time, of course. Also by email, that's another way. I'm pretty good at responding to emails. So I have two email addresses that you can use. The one that I put on the syllabus is my Gmail address, but there's also my STLCC address. Okay. All right. Homework, right now I'm planning on 11 homework assignments. Now, for those of you who took this class last semester, you'll notice that the points for the homework have increased. I'm now going to have each homework assignment be worth 25 points. And the reason is that doing the homework is really important to grasping the material. So the only way I thought of doing that was to just up the ante a little bit as far as the points that the homework is worth. Right. I do post all the grades on Blackboard, so be familiar with Blackboard. You use your user ID and password to get onto that. The grades will be posted on Blackboard. Other documents, homework solutions, take-home quizzes, once they're over, the solutions to those. Test solutions get posted after the test. And, all right, after the test, that you're supposed to laugh then. And so there's all kinds of stuff that's posted on Blackboard.
I have a question.
Yes.
Around here it says you don't post any notes online.
Oh, do I say that? That is a false statement. Thank you, Nikesha, for saying that, seeing that. Absolutely false. And you can tell my proofreading didn't catch that one. I do post notes online. So please scratch that out there at the bottom of the first page. In fact, what I do is I scan the class notes. I have class notes that I work from, and then I have my class notes that I make while I'm here. I think I'm going to end up posting both of those set of notes on Blackboard, and it'll have their own folder, okay? I guess while I'm talking about things posting on Blackboard, another thing that I do is I record the lectures. In fact, it's hopefully recording right now. And those get converted to a YouTube video, and those then will get posted to a special folder right there on Blackboard. So you can use those for days that you're unable to attend class, or if you want to hear something again. All right, so those are available. All right, where do we want to go here? Thank you for that. All right, then this is on page 2 of the syllabus then. I do see somebody from Eureka. Hello, Harry. At least one person is there. Harry, is there anybody else there with you? So, quizzes. Occasionally we'll have in-class quizzes, brief and just worth 5 points. So we'll play that by ear. And you can use a non-graphing calculator on any in-class or out-of-class assignment. So you can. Thank you. What do we have going here? The juniors have a class meeting. Annalie is at the counselor's. Okay, I don't know where Jake Massman is. All right, well, thanks, Harry, for that. I tell them I am recording this so they can either look at your notes or just look at the video, okay? Anyway, welcome back. All right, take-home quizzes. There's going to be 4 tests, so there's 4 take-home quizzes, and those will be due at every test. Those I'm having now worth 50 points each. Previously, those were worth 25 points each. They're now going to be worth 50 points each. So again, I'm upping the ante. And by the way how I grade both the homework and the take-home quizzes for you new guys is that I randomly select usually 5 problems to look at, and I grade the 5. All right, so those are the ones that count for the score. All right, take-home quizzes. Okay, obviously, I want you to show work in order to get credit. Now, I'm not going to be dropping anything, by the way. No quizzes, homeworks, nothing. I'm not going to drop anything. All right, scientific calculator. Yeah, I do recommend that you guys have a scientific calculator. If you don't have one for an in-class test, we have some here that we can provide you with. Okay, for tests, closed book, closed notes. Sometimes I do provide handouts with some information on them, but sometimes there is a lot of material to memorize, so I try to help a little bit with that, with maybe providing some formulas, all right? But otherwise, closed book. Oops. Let's see what we got here. Oh, okay. Okay, there's a question about rescheduling the final exam. Yeah, we'll have to deal with that. Thanks for the heads up on the final exam. We can arrange it for another day if there's a conflict, okay? Yeah, that's in May. Let me make a note to myself on that. Okay. All right, and also prior to each, certainly doing the take-home quizzes is good preparation. Of course, the homework for doing the test. And then I'll also be providing a practice set that you can have. Those won't be graded, but they'll help prepare you for the exams. If there's any reason that you're not able to be there at a test, just let me know ahead of time and we can make arrangements for you to take the test at another time, all right? All right. And then final exam, that's on Monday, May the 12th, and it is mandatory and it is comprehensive. Okay. Any questions yet, other than what we've had? All right, here's, let's see, page 3 here. I do offer some bonus points on some of the tests. There could also be assignments which are considered bonus point problems. All right. And Joseph?
No, I think it was nice.
Oh, all right. Okay. May I have your name, or maybe? Why don't you put your last and first name down there?
Do I need to put a year or
No, don't worry about that. Just your last name and first problem. Okay. I had talked about Blackboard before. I do encourage you to check that routinely. Grading. All right. Right now we have a total of 1,450 points, plus any extra points that happen from any of the in-class quizzes. So notice that attendance, I do count attendance as part of your points, so that's 75 points there. So I do take note of who is here, who's not here, and mark that. Homework, 11 homework times 25 points, that's going to be 275 points. The 4 take-home quizzes, 4 times 50, 200 points. The 4 exams, each one's going to be 150 points, that's 600. And then the final exam is worth 300 points, so that's adding up to the 1450, right? And basically, I don't curve anything. It's basically like 90% or up is an A, etc. Except I usually start my A's at 89.45 just for rounding purposes, all right? And B's at 79.45. Okay. The free tutoring, it's limited. There's really only one tutor, correct? Are there 2 that are okay with calculus? Oh, Mike is, okay. So Amy and Mike downstairs, there are two individuals that know calculus. The other tutors are for the more basic algebra classes. So I do encourage you also to take advantage of them. That's in that big round or oval table there, right in that big room downstairs in the first floor. All right. And then some dates here. We don't have class this coming Monday, and we don't have class on President's Day. We have spring break in March. Last day to withdrawal is Friday the 11th. Last day of class is Monday the 5th. And the final exam is on Monday the 12th. So all those dates are there. All right. And let's see. Okay, even though I do record things and I do encourage you to actually attend class because that way you can directly ask questions. You can't ask questions of a recording unless there's a strange coincidence in which I just happen to answer that question when you think of it. So I do really encourage you to attend class. If you're not able to attend class for a reason, I do also appreciate if you just shoot me an email just as a courtesy to let me know that you can't attend. All right. Okay, I've talked about only non-graphing calculators are allowed, are allowed. Graphing calculators are not allowed for the in-class test. Let's see, evaluation, stay together as a class. Okay. Withdrawal by the Friday the 11th. If any of you have special needs for a test taking, perhaps you would need to go to the access office downstairs and provide me with paperwork on that. Okay. All right. And then a lot of this is blah, blah, blah stuff. Academic integrity, of course, we don't want you copying off of someone else. I know for homework, I know you can certainly work together in homework and that type of thing. I don't care outside of class. What isn't very helpful for you, though, is if all you're doing is copying someone else's answers. That I don't know how helpful that's going to be for you to do that. All right. It's helpful in the short term, maybe, to get the homework problem maybe correct if the other person knows what he or she is doing. But if you don't understand it, it's kind of missing the point of the homework. And that goes for the take-home quizzes also. All right, and of course I reserve the right to make changes as needed to the syllabus and course calendar. All right. Also here, and this is also posted on Blackboard, and I also posted one of these for last semester. because one of the high school students actually had notified me that they really needed an official course profile on what we cover to apply for credit at another institution. All right. So a course profile for this class and also a course profile for the second semester are both on well, you have it here, but they're also posted on Blackboard. All right. So you may need something official to indicate what has been covered in each one of the classes. All right. And then let's just look here at the tentative schedule. This will look pretty familiar in the format of it for those of you who took this class here last semester. Basically breaks it down every week into what sections I'm planning or hoping to cover for each week. So we see that for this week, 12.1 through 12.4, but then next week I also have 12.4 in there too, because we may not completely finish it, so we'll just continue on next week. It also indicates the third column, homework, the various homework assignments, 1, 2, 3, etc., and the date that I have them due. So what I will be handing out next time, I'll hand out the first homework assignment so you guys can get started on that. I'll also be posting the homework assignment on Blackboard too, in case you need another copy of it. So notice the first homework is due a week from Friday. And most of those, I believe, we have them due on Friday. In on the next column over, we have the take-home quizzes. There are 4 of those, and if you notice, those are due when we take the various tests. And then in the next column, the test, the first test 1. Test 1 is on chapters 12 and 13, and that's scheduled right now for February the 7th. And it looks like the way I've got things here that we won't be, there was an issue last semester with starting some new material prior to taking the test. So it doesn't appear, I don't have it working that way, that we're going to be jumping ahead to anything new before the test is taken. So you can be focusing on the material at hand for the test. And the last columns are just various notes about days that we have off and spring break. So that's on the front and the back, 2 sides. And then at the back, we also indicate the final exam date. And any changes I'll announce in class and also put on Blackboard. Okay. All right. So that's our schedule. Okay. On Blackboard. Charles, if you have any questions about things that you missed, then you can see me after class or email me, whatever is more comfortable with you. All right. All right. So I guess we can start on section 12.1. Let's go for it, huh? Jenna, yeah, I can always read Jenna's mind, and she's thinking, no, let's not go for it. Let's go home instead. I have to have a scapegoat in every class. All right. Okay. Yeah. So, right. Thomas is here. Just checking out people who are here. All right. So, what we start out here in section 12.1 is it introduces just the 3-dimensional coordinate system. So, you are used to, of course, the X and Y axis, the two-dimensional axis, X and Y, that's no big thing to you, but now we're going to add another axis to it, a Z-axis. So to show something here, what routinely you have is it drawn like this, where the thing that the axis that is coming out to the, seeming to come out to the front is the X-axis. The one over here then is the Y-axis, and then the one going vertically up is the Z-axis. So it's X, Y, and Z, with somehow looking at the X-axis is coming out at you. What I've posted here on Blackboard, you can print these out and make copies for yourself, is basically a three-dimensional graph here, where you have the X-axis, the Y-axis, and the Z-axis, and here is the center of it. And I'll do an example of this in a few minutes if we get to it today. So this is a 3D graph, and you can print that out online. All right. The arrows here point in the positive direction. All right. So there are three axes here. There's the X, Y, and Z axis. Three axes, X, Y, and Z. All right. Now, there's something called a right-hand rule, which indicates how the let's see, what do I want here? PC, right? Yeah, there we go. All right. Okay. Which determines the direction of the Z-axis. Basically, if you take your right hand and you start curling it around where it starts to curl around the positive X-axis in the direction of the positive Y-axis. So like this, where this is the positive X, this is the positive Y, then this is with the right hand. Then the thumb, the direction of the thumb upward, is going to be the direction of the positive Z-axis. So that's called the right-hand rule, and that's what we'll be using with how the Z-axis is coordinated with the X and Y-axis. All right? Okay. Now, in the two-dimensional system that we use, right up here, we had what is called the XY plane. So in the X and Y direction, we had a point that had two coordinates. They stretched in either direction, and they formed what's called a plane. Well, here with the X, Y, and Z, we actually now have three coordinate planes. We have a plane for the XY axes, just like we had before. So we have this plane right here, XY plane. Oh, that's right, thanks. I got to get back in the, thank you, back in the saddle with this thing again. We have the XY plane. Then, if we looked at the combination of, say, the X and the Z's, we have an XZ plane. And if we look at the other combination of the Z's and the Y, we have a YZ plane. You can actually think of it as like looking at a building, and the corner of the room could be looked at as, say, the origin, 0, 0, 0. And then basically the floor here could be looked at as the XY plane, all right? Going up, that can be looked at as the Z-axis, all right? So that wall over there going up and down throughout the building can be looked at as the XZ plane, all right? This wall here where we have the y-axis going all the way up and down can be considered the YZ plane. So you can look at it as like walls in a room. Over here, let's see. All right, you guys can see that. This is a little bit better drawn, where we're showing here the XY plane, which is formed by the X and the Y axis, and then the XZ plane, which is formed by the X and Z axes, and the YZ plane by the Y and the Z axes. One thing you want to remember about these is this. On the XY plane, at any point in that plane, Z is equal to 0. So the letter that you don't have, Z, for the XY plane, that's equal to 0 for every single point that's on that plane. For the XZ plane, we're not seeing the letter Y in that, XZ. Y is equal to 0 for every single point on that plane. And then finally for the the YZ plane, we don't see the letter X in that. X is equal to 0 for every single point on that plane, all right? Just like similar in the two-dimensional case, when we talked about just the X and the Y, along the Y-axis, X was always equal to 0 along the Y-axis. Along the X-axis, Y was equal to 0. All right, it's a similar situation there. Okay, so what I want to look at next is just using this 3D paper to just show how we can put, at least plot a couple of points here. First of all, let me plot, so this is called 3D graph paper. All right. And let me plot this point here, -4, 3, and -5. Now, the first number, of course, is the X number. The second number is the Y number. The third number is the Z. All right. So here we have our X-axis right here. This is the positive direction here for the X. This is positive for Y. This is positive up here for Z. So we kind of just do this in steps. Okay, we want to first of all, go back 4 units to get the -4 for the X. So we can start here at the origin where we have 0, 0, 0. Since it's a -4, we have to go in this direction, the negative direction. So if you can, it's really hard or impossible for you to see the details on this, I'm afraid. 1, 2, 3, 4. If you can, I'm afraid the lines are too fine for you to really see the details, but I'm going back 4 along the X-axis, okay, because it's -4. All right, so I'm at that point. Now I have a +3 for the Y. Now the Y is in this direction here. So I need to go a +3, so now I'm going to go 1, 2, 3 for the Y. So far I'm right there. Then finally I need to figure and go to my Z. My Z is the up and down. Z is -5, so I need to go down to the negative area 5 steps. 1, 2, 3, 4, and 5. And then right there is my point, -4, 3, and 5. So it's a little bit trickier. You obviously need an additional step. You have to be a little more careful, perhaps, in plotting these points. Let me do one more point. 3, -2, and -6. So let's just start with our X. Our X is a +3, so now I'm going to be going in the positive direction from the origin, 1, 2, and 3. So that gives me right to that point there. And then my y is negative 2. So my y is this way, this diagonal this way. I need to move in the negative direction, which is up in this direction, 2 units. So 1, 2. So that gets me there. And then my z is a negative 6, which means I have to go down now. So that's my starting point. I go down 1, 2, 3, 4, 5, and 6. And then that's the point that I end up at. All right. When you can see the grid a little bit more clearly, I think you shouldn't have any trouble with it. All right. A couple of notational things. You may or may not have seen this in your first couple of semesters of calculus. R3, and that R has another little line off to the side of it. So capital R3. This really means the set of all triplets, ordered triplets of real numbers. So it's the set of all ordered triplets of real numbers. So it's the things x, y, and z, such that, let me put brackets here, such that x, y, and z are a member of the real numbers. Okay, ordered triplets, R3. That's how you say it. Then similarly, we have R2, which is the set of all ordered pairs, which is what you're used to from the previous semesters. The set of all ordered pairs of real numbers. So R2 and R3. All right. Let's look at this question here. Just kind of getting used to this three-dimensional drawing. What surface in R3, so we're talking about 3 dimensions here, is represented by the equation y equals 5. All right. Now, in R2 from previous semesters, y equals 5, we would just go up 1, 2, 3, 4, 5, and it would be this straight horizontal line, right? Okay, that's in R2. But now we're talking about R3, so we need to be looking at the x, y, and z axis here. So let's start with x, and, ooh, that one's not doing well, and y, x. And then z, all right, and figure out what does the surface look like. Okay, well, let's see here. Y is equal to 5, and that's our only constraint on the surface. So basically, it is the set of all points in R3 whose y coordinate equals 5. All right. And otherwise, x and z can have any value whatsoever. So if we look at this, okay, here's our positive y-axis. We go 1, 2, 3, 4, 5, right there. All right. Now, it can have any value of x, so we can go in this direction, we can go in this direction, and it can have any value of z. So it can also go up like this, and up like this. It can go down. It can go down. So what we really have is a plane. This whole area right here is this big plane where everything that they have in common is the fact that the y-coordinate is equal to 5. So another way that I could describe this equation is this. It's a vertical plane because it certainly goes up and down. The vertical plane parallel to, okay, what axis, what coordinate plane would this be parallel to? Would it be parallel to the xy plane, the yz plane, or the xz plane? Be parallel to the xz plane. So it's parallel to the xz plane, and it's 5 units up in front of it, to the right of it, and 5 units to it. Because of the directions we're using, 5 units to its right. We're going in the positive y direction. So in R2, something like y equals 5 is just a straight line. But in R3, something like y equals 5 is this whole big plane of points. I think we'll do one more and then we'll call it a day. A similar kind of question here. What points in, again, R3 satisfy the equation? Now here we have one equation, x squared plus y squared equals 1. But we also have an additional equation, and z is equal to 3. All right. Now, certainly we know that in R2, x squared plus y squared equaling 1 is a circle. It's a circle whose center is at the origin and has radius equal to 1. Okay, that's in R2. In R2, though, we don't have any z, but I just wanted to point out, well, we have a circle there. So let's look at R3 here. So let's go out for our x, our y, and up for our z. All right. And first of all, okay, z is equal to 3. So we're going to go up 3, 1, 2, 3 in the positive direction. And these set of points is going to lie on that horizontal plane where z is equal to 3. And that's a horizontal plane that's parallel to the xy coordinate plane. All right. So now the thing is, we have to have x squared plus y squared equals 1. Well, if we were just looking at x squared plus y squared equals 1, we would have circles around the z-axis, and they would go up and down for any value of z. So this would give us a cylinder all the way up and down, okay, for x squared plus y squared equals 1. But we are then restricting this to just z equals 3. So 1, 2, 3, we're going to just be looking at this circle where z is equal to 3, and it has radius 1. So this is a way to draw this. A way to describe it is this. The points that lie on the horizontal plane z equals 3 and form a circle of radius 1. with the center, that would be 0, 0, and 3. X would be 0, Y is 0, and Z is equal to 3. All right. So that would be what that particular surface would look like. It would just look like a circle suspended up 3 units. Okay? All right. So we'll finish up first thing in class with a couple of other things in this section, a distance formula and the formula of a sphere. We'll finish that up at the very start of class next time, and then get started on sections 2, and we'll see how far we go from there. All right? Thanks a lot.
Very good for somebody Anyway, whatever.
Oh, well, I just basically just went through, I don't know where you came in as far as the syllabus is concerned. You probably don't, we're probably wondering what in the world I'm doing over here.
I can guess, sort of.
Well, we have 2 remote high school classes, students at Eureka High School in Lafayette. And yeah, so they're able to view us review me remotely in here. I also record the lectures.
Okay.
So if there's days that you're not able, and I post them as a YouTube video actually online. I also scan my class notes and post those online. So I want you to be here in class, but if you're not able to make it, you do have material available, not being here. And I think that's pretty much what you missed. All right. Okay.
So, I was just curious about the high school thing. So, what do they do once they view the lecture, like in terms of getting comfortable with this process?
Well, usually they form a pretty good peer group and they're helping each other.
Okay.
That's what I found. But they would have to pretty much email me. I rarely ever see them.
Okay.
Now there were a couple of days last semester where they were off school, we had school here, and a couple of them would come into class, and it was nice to be able to see them.
Right.
At the very beginning of last semester, I went to the various 2 schools and talked with them directly, but they're all just, or most of them are just continuing, so I didn't go out there. But yeah, so they have to email me. It's maybe a little bit of a challenge, but it worked out pretty well last semester.
My mother studied in electrical engineering in China, and some of her classes were like this too, except they would show the classes up. Like, you know how there's a public access TV channel here, right? It was basically the same way. They would watch the classes on TV, and then they would do the homework.
Right. Yeah, they each have an instructor there in the classroom with them. One of them is actually a math instructor who taught them AT calculus. Okay. The other one's kind of an engineering guy. Okay.
So do you teach her both sides?
I'm an adjunct here. I teach this in college algebra here. At UMSL, I teach Introduction to Differential Equations. I'm doing that this semester.
Is that equivalent to the differential equation class here, or is that
I would imagine it's pretty equivalent, because here it would only be also an introduction to differential equations. I haven't looked at the course profile here to compare it against UMSL's, but I'm sure there's a lot of similarity. Yeah, that's a lot of fun to teach. The students of all, they've had the 3 semesters of calculus. It was interesting. I did a poll with them saying, which of the 3 semesters was the most difficult? Let me ask you that question.
So I've actually taken all 3 semesters before. I watched you have taken time off. So I guess.
Did you find any one of the 3 more difficult? Did you have it as the 3-semester class?
I did. Let's see.
I'll put you on the spot. Well, let me ask you this. Did you, I'm sorry, never mind, because you haven't had all 3. You had all 3?
Right.
Oh, so why are you taking?
Oh, I'm retaking it. It's been a few years since I talked with 3, so I reinforced.
Oh, gotcha. Okay. I don't know why I'm asking you this, because you've only had 2 semesters. Oh, well, they all said, so they had all 3 semesters. They all said that the 2nd semester was the most challenging. Really? And I have talked to people who said the 2nd semester was easier, but they all seem to pretty much go with it. that can be the hardest. With all the trig integration,
Like, yeah,
and series, it could be a problem.
right, yeah, I agree with that.
Yeah.
Okay.
Anyway. Well, I hope you continue.
Of course.
All right, good. Very good. Did you have a question?
I was just curious, do you cover forward stuff in here?
Yes, we do. Let me see here. I need to do something here.